Our math warm-up today involves conversions. So take a look at the table I have here for you. If you would, number your board or paper from 1 to 4. Pause your video and see if you can do those conversions real quick. All right, let's have a look here. 3 feet is equal to 36 inches. And how do I know that? Because there are 12 inches in 1 foot. So 3 times 12 would give me 36. Second one, 6 feet would be equal to 2 yards. So I know that there are how many feet in a yard? That would be the question, right? 3 feet in a yard, so 6 divided by 3 is 2. Third one, 4 1/2 feet is equal to 54 inches. How'd you do on that one with that fraction? And the last one, 2 feet is equal to, this one's a little tricky, 2/3 yards. Because once again, there's 3 feet in a yard. The fact that we only have 2 feet, we end up with a fraction for our answer. For our math message today, you're going to need your student math journal, and you're going to open that up to page 240. And at the top of the page is going to be your math message that looks like what you're seeing here on the screen. So if you want to pause your video, grab your materials, and come on back. Okay, so the math message today states, find the area of the rectangle. Report your answer in square feet. So we have a rectangle here, but what I'm noticing is we have mixed numbers for our measurements. So see if you can try to figure that out. Pause your video and come on back and we'll discuss strategies. Okay, so there's several different ways that we could go about solving this problem. One of the methods would be to use partial products like we've done in the past, where we could use an area bottle if we needed to draw a picture, take that 5 1/2 and the 8 1/2 and decompose it, and then go ahead and multiply to get our answers. Another way to go about it would be to rename those factors as fractions and then go ahead and multiply them out. And then a third way would be to convert the dimensions to inches and then multiply. So there's several different ways that we could go about this, but my personal preference is to just go ahead and change the mixed numbers to a fraction and multiply it out. So if we do that, 8 1/2 is going to turn into 17 halves, and 5 1/2 is going to turn into 11 halves. And then we multiply that out using our multiplication algorithm. We get 187 as our numerator and 4 as our denominator. And then we could turn that into a mixed number, and we're going to get 46 3/4. So our answer would be 46 3/4 feet. Can't forget that label. So again, it's going to be personal preference as to what method that you choose to solve that problem. And maybe you weren't quite sure how to start the problem to begin with. So now you have an idea. So our lesson today is all about rectangles with fractional side lengths. So the reason we're doing this lesson today is we're going to use our understanding of fraction and mixed number multiplication to show that the area found by tiling is the same as the area found using the formula. And how we're going to do that is we're going to hopefully see the relationship between tiling and using the area formula, and we're going to be testing the theory to see that we get the same answer using either method. So, as a reminder, we have learned in the past that there is a formula for finding the area of a rectangle. And that formula is area is equal to length times width. So, thinking about that particular formula, this is what we've done in the past, where we had a rectangle, we were given measurements, and those measurements were in whole number increments. So if, for example, this one was 3 inches by 4 inches, we would multiply length times width. 3 times 4 would give us 12 inches for our area. The other thing that we've done in the past is we have covered that particular area with unit squares. So each one of these unit squares would represent 1 inch because our unit was an inch. So here you can see with a picture that I would have a total of 12 squares or 12 square inches for this particular problem. Okay, so let's take a look at what happens when we have fractional sides. So remember, in the past, our problems have had a whole square inch to work with. So when we think about and talk about fractional sides, that means that we're taking that 1 square inch and we're making it into pieces that are smaller than what we would call the whole. So let's do a couple of examples here to kind of give you an idea of what I'm talking about. So let's say that we have the problem 1/3 times 2/4, for example. So what I would do is I would take one of these square inch tiles and I'm going to divide it up into thirds for the first example because our first factor is 1/3. So I'm going to divide that up into thirds. Then I'm going to go the other direction and divide it into fourths since my other factor has 4 as the denominator. So I'll make that in half and then divide each of the halves. Okay, and now I'm going to go back to shade what 1/3 would be. So this would be 1/3 shaded this direction. And then I'm going to shade 2/4. So I'm going to shade, this would be 1/4, 2/4. So what we're going to look at is where those colors overlap. And I know that's hard to see here on this blue background, but they overlapped here and here. So that means that my answer using an area model would be 2/12. Well, watch what happens over here when I multiply my length times my width. So use my multiplication algorithm, 1 times 2, my numerators. I get 2, and multiply my denominators, 3 times 4 is 12. Well, we got the same answer, didn't we? So let's try another one. Let's say that for this one, I'm going to do 2/3 times, let's do 1/6. So again, I'm just going to pick a random square here. So we're going to divide that into thirds. And then we have to divide into sixths going the other direction. And you'll have to ignore my other lines that you can faintly see there. I was trying to get some graph paper to actually be able to use, and it just wouldn't show up here. Okay, so not the best drawing, but you kind of get the idea there. So we're going to take a look now at 2/3. So what would I shade in for 2/3? I'm going to shade in this whole section here and this whole section here. And then I'm going to take my other color to shade in 1/6 and look to see where they overlap. Well, again, there's only two spots where they overlap, which would be here and here. So let's check it with multiplication. I get 2/18. Well, if I look at my area model, I have 2/18 as well. Okay, so let's take a look at this particular problem, and I'm going to turn this over to you and give you a turn or a crack at it. So let's say that we have a rectangle that is 9 inches for my length and 6 1/4 inches for my width. So I'm going to let you make the choice whether you want to try to draw an area model or if you would like to use the area formula to multiply the length times the width. So go ahead and pause your video and come back and check when you're ready. So I don't know about you, but I was a little overwhelmed looking at this problem thinking, how do I create an area model? So I went with I'm going to change the factors both into fractions. So as you can see off to the left, I have taken the whole number 9, changed it to a fraction, took the 6 1/4, converted it to a fraction, went ahead and multiplied those together, got 225 over 4, and then I turned that into a mixed number, which gave me an area of 56 1/4 inches squared. Okay, we hadn't talked about that unit or how we square our answers, but remember, when we're thinking in area, it's usually square units, so we need to make sure that we give that in our final answer. So to summarize what we've done today, we learned that we can find area of rectangles with fractional side lengths by creating an area model, which works when we have somewhat smaller fractions without mixed numbers. And then we also learned that we can use the formula for finding area of a rectangle and take our fractions or mixed numbers and turn them into all fractions and multiply them out. Feeling pretty good about that? I hope so. Happy thoughts. Until next time.